You lived a complete life before you turned 3. You were born. You opened your eyes for the very first time. You heard the sound of your mother's voice. You tasted food. You took your first steps. You spoke your first word, and you remember none of it. Not a single moment. Most people think the explanation is straightforward. Your brain simply wasn't developed enough. You were just too young. But that's not the whole truth. And the real explanation is far stranger than most people expect. Because your infant brain wasn't failing to record your life. It was recording everything. Your memories existed. But something came along and erased them. In 1905, Sigmund Freud became the first person to give this phenomenon a name. He called it infantile amnesia. Infants are capable of forming memories. Heck, we know this with certainty. In the 1980s, psychologist Carolyn Rovee-Collier at Rutgers University designed a clever experiment. She attached a ribbon from a baby's ankle to a mobile hanging above their crib. The babies figured it out quickly. Kicking made the mobile spin, and they were delighted by it. When she brought the same babies back days later, they hadn't forgotten. They started kicking the moment they saw the mobile. Even 2-month-olds held onto that memory for a few days. 6-month-olds retained it for weeks. So the infant brain can learn. It can store information. It can retrieve it. But those memories don't stick around. By adulthood, every trace has vanished. And for decades, scientists struggled to fully explain why. The first part of the answer is structural. The hippocampus, a small curved structure buried deep in the brain, is the engine that drives memory formation. It takes a lived experience, a birthday, a conversation, a walk in the rain, and encodes it as an episode you can revisit later in your mind. In adults, the hippocampus works alongside the prefrontal cortex to tag, store, and retrieve these episodes. But in infants, this system is severely immature. The connections between the hippocampus and the cortex are still under construction. Critical regions like the dentate gyrus, which serves as a gateway for incoming memories, aren't fully wired until somewhere between ages 2 and 4. So your infant brain could form short-term memories. It simply couldn't transfer them into long-term storage the way an adult brain does. But that's only part of the story. And honestly, what comes next is even more unsettling. In 2014, 2 neuroscientists in Toronto discovered something that completely reshaped how we understand infant memory. Josselyn and Frankland at the Hospital for Sick Children proposed a hypothesis that sounded almost absurd at first. What if the very process that constructs your brain is the same process that wipes your memories clean? Here's what they meant. In the first years of life, your hippocampus generates new neurons at a breathtaking rate. This is called neurogenesis. And it's essential. Those new brain cells are what forge the circuits you'll rely on for the rest of your life. But Josselyn and Frankland suspected there was a price to pay. Every time a new neuron weaves itself into an existing circuit, it disrupts the connections that were already there. The very connections that were holding your memories in place. To test this idea, they ran experiments on mice. When they artificially accelerated neurogenesis in adult mice, those mice began forgetting things they had already learned. When they slowed neurogenesis in infant mice, the young mice held onto their memories far longer than normal. The results, published in the journal Science, pointed toward a deeply counterintuitive conclusion. Your baby brain wasn't too fragile to hold memories. It was too preoccupied with growing. The same explosive burst of new neurons that assembled your brain was simultaneously overwriting the memories stored inside it. Your earliest experiences weren't lost because they were never captured. They were lost because your brain kept adding new rooms while tearing down the old walls to build them. But there's one more layer to this, and it might be the strangest part of all. To form what scientists call autobiographical memory, the kind where you are the central character of an experience you can consciously replay, you need something most of us never think twice about. You need a sense of self. You need to understand that you exist as a distinct person, separate from the world around you, and that things are happening specifically to you. Developmental psychologists Mark Howe and Mary Courage argued in the late 1990s that this is the critical missing piece. Before roughly 18 to 24 months of age, infants don't perceive themselves as separate individuals. The classic test is elegant in its simplicity. Place a small dot of rouge on a baby's nose and hold them up to a mirror. Before 18 months, babies treat their reflection as another child. They don't reach for the mark on their own face. After 18 months, they do. They recognize that the person in the mirror is them. And that moment, the emergence of self-recognition, closely aligns with the earliest point at which autobiographical memories can begin to form. In other words, you can't remember being a baby partly because there was no you yet. Not in the way you experience yourself now. There was no narrator inside your head, packaging experiences into a story that belonged to a person called you. Which raises an uncomfortable question. If you had no continuous sense of self, and the brain that held your earliest experiences physically rewired itself beyond all recognition, is the baby in those old photographs actually you? Or is it someone else entirely? Someone who shared your body but whose mind was literally dismantled and rebuilt, neuron by neuron, into the person you eventually became. There's one final piece: language. Developmental psychologist Catherine Nelson spent years investigating how children form lasting memories. Her conclusion was striking. Language doesn't merely describe our memories. It gives them shape. Before you could speak, your experiences were encoded as raw sensory impressions. Sounds, textures, emotions, but without words to organize them, those impressions had nothing to attach to. Once children begin speaking, and especially once they start discussing past events with the adults around them, things like, "Remember when we went to the park?" Their capacity to form lasting memories improves dramatically. Language gives memory a skeleton. Without it, experiences are like water poured onto open ground. They exist for a moment, then they're gone. And this isn't purely theoretical. Psychologist Chi Wang at Cornell found that the age of your earliest memory actually shifts depending on the culture you were raised in. In Western cultures, where parents regularly narrate their children's experiences, asking questions, telling stories, building personal histories, earliest memories tend to begin around age 3.5. Among the Maori of New Zealand, whose oral tradition places extraordinary weight on personal narrative and storytelling, average first memories reach as far back as age 2.5. In certain East Asian cultures, where early childhood narratives focus less on individual experience, first memories tend to emerge closer to age 4 or even later. The culture you grew up in literally determines how far back your memory can reach. So here's what actually happened to your earliest years. Your hippocampus wasn't ready to build long-term memories. And even when it began to, the flood of new neurons tore through the circuits that held them. You had no concept of self to anchor your experiences to, and you had no language to give those experiences a structure that could survive. It wasn't one single thing. It was everything, all converging at once. Every human being who has ever lived went through this. Every person you have ever known carries a black hole where the first years of their life should be. And the answer to why isn't that your brain was too primitive. It's that your brain was doing something far more significant than remembering. It was becoming you. And that required quite literally erasing the person who existed before.